All right, so let's take a look at some of these examples here. We're supposed to identify holes, asymptotes, intercepts, if any, and then state the domain. Okay, so in my notes, the way you are able to figure out if a function, a rational function, has any holes is basically you need to factor the numerator. So over here, my numerator, I can't really do anything. And then factor the denominator. So this is just simply x plus 2, x minus 1. And then after you factor it, right, notice or try to decide if there's anything that you can cancel. And there's no common factors that I can cancel. If that is the case, then you can just simply say none. Okay, so there are no holes, nothing really canceled out. All right, so the next thing you can do is find the VAs, and the VAs are pretty straightforward, right? You simply set the denominator equal to 0 and solve for x. So you can have multiple vertical asymptotes, as you can see in this particular example. So over here, I have two VAs, x is equal to -2, and then x is equal to 1. All right, now the horizontal asymptote is a little bit more involved, right? You have to compare the degrees of your numerator and denominator. So I would say the degree over here in my numerator is 1. The degree in my denominator here is 2. So clearly 1 is less than 2. If that is the case, if the numerator degree is less than the denominator degree, then we say therefore y equals 0 is my HA. Okay, so that's just something you have to memorize. All right, so next step is to find the intercepts or the zeros, if any, and just a quick shortcut, right? Normally you set fx equal to 0, but what I can do is just simply write 0 is equal to 3x. And the reason why is because if you just look over here, right, 0 times x squared plus x minus 2, if I were to cross multiply this guy right here, it just becomes 0. So as a line to save a little bit of work, you can just simply set 0 equal to the numerator. Okay, so when you solve for that, you're simply going to get x is equal to 0 as one of your zeros. So this is for the x-intercept. And then the y-intercept, right, we plug in x is 0. So let's do that. And it looks like we are also going to get 0 as well. Okay, so sometimes your x and y-intercepts happen to be the same point. In this case, the origin. All right, and then the very last step, of course, is state the domain. Basically, I'm going to go back and look at my vertical asymptotes, which are right here, and I'm going to exclude these values, right? X can't equal -2 and 1, because if they were equal to -2 or 1, right, you would be dividing by 0, which is not allowed. All right, let's move on to the next example, number 4. All right, so you have 3x squared minus 8x plus 4 over 2x squared minus 3x minus 2. All right, so again, the way we figure out if we have any holes is we simplify the numerator and denominator. And so what that tells you is that your factoring needs to be wrong, right? Let's factor this. So over here, I have 3x times x. If it's minus plus right here, it's going to be minus minus. And then factors of 4, you can use 2 and 2 or 1 and 4, 4 and 1. It looks like 2 and 2 will give you that middle term, okay? So you can verify if I factored this correctly and just by foiling. Over here, my denominator here, I'm going to write 2x times x, right? Because 2x times x will give you 2x squared. And then I could use 1 or 2 or 2 and 1. Because the middle term right here is a -3, I'm going to use 1 and 2. And I'm going to write minus and then plus. Okay, so notice this time, right, we have x minus 2 as a common factor here in the numerator and denominator. And what happens is you cancel that out, right? And in the notes I wrote, whatever you cancel out, the canceling factor, in this case x minus 2, right? I set that equal to 0 and I solve for x. So what I've just found is the x value of the whole. Now, returning back to my original function over here, right? If these x minus 2's cancel out, my simplified or my new function is just this. And so here's a key concept, right? Now you are only analyzing the simplified function. And not only are you analyzing the simplified function from this step on, right? You also need the simplified function. You need to plug in the x value into the simplified function to get the y value of the whole. So let's just do that really quickly. Well, let's take x is equal to 2 and plug it into the simplified function to evaluate. Over here, I'm going to get 6 minus 2, which is 4. And over here, I'm going to get 4 plus 1, which is 5. Okay, so 4/5 is the location of the y value of the hole. So at the end of the day, your hole is ultimately located at 2, 4/5. Okay, so if you're wondering what a hole is, right, it kind of just means what it sounds like. It's just an open circle at 2, 4/5. And that's pretty much how you figure out a hole. Not super difficult. It's just, a lot of different steps and procedures that you have to follow. Okay, so now going back to the VA, right, I'm not going to go back to the original function. I'm going to analyze the simplified function. So in other words, I'm only going to set 2x plus 1 equal to 0 and solve. Okay, so I'm going to get x equals -1/2 as my VA. And then to get to HA, right, I need to compare the degrees. Again, I'm using the simplified function. So notice the degree of the denominator is 1. The degree of your numerator is also 1. So 1 equal to 1, right? All right, so if that's the case, then if you look at your notes, what I wrote down is if the degrees are the same, it's the ratio of the leading coefficient. So the leading coefficient in the numerator is 3, leading coefficient in the denominator is 2. It's simply 3/2. Okay, so again, this is just something you need to memorize. If the degrees are the same, it's the ratio of the leading coefficients. And that's pretty much it in terms of new concepts. Let's get the x-intercepts, right? Again, a little shortcut I showed you is instead of setting the whole thing to 0, f of x equal to 0, right? What you could do is simply set your numerator equal to 0. Okay, so I'm going to set 0 is equal to 3x minus 2, just to save us a little bit of work. X is equal to 2/3 is your xint, and then the yint is a little easier to find, right? Just simply evaluate for 0. So 3 times 0 minus 2, 2 times 0 plus 1. It looks like you're going to get -2 as your y-intercept. Okay, now be careful when you state the domain. This is the only time I would say you probably have to go back and look at the original. You're obviously going to have to exclude your vertical asymptote, right, which is -1/2, but you also need to exclude your hole value. Remember, a hole value is located at x is equal to 2. So when you look at the original, right, you're excluding x is equal to -1/2. You're also excluding x is equal to 2. That's what I mean by this is the only time you have to look at the original. Okay, so all x can equal -1/2 and 2. All right, let's do one example. Let's see, this is number 4. That was number, okay, so number 5 in your notes. F of x is equal to 2x squared plus 1 all over 3x squared plus 1. Okay, so really quickly, right, just a quick glance at the function right here. I can't have any holes, or I don't have any holes because nothing cancels out. So I'll write A or none, either one's acceptable. The VA, look what happens when you set the denominator 0 on this one. You're going to get 3x squared is equal to -1. X squared is equal to -1/3, right? Extract the square roots on both sides. Obviously, you have to write plus minus. Okay, so you're going to get a non-real result, right? If it's not real, sure, you could write plus or minus I, square root of 1 over 3, but we only care about the real axis. This implies there are no vertical asymptotes. So not all rational functions have VAs. It's a major idea, a major concept. Okay, the way you find the HA is still the same. Compare the degrees, right? The degree of the numerator is 2. The degree of the denominator is also 2. 2 is equal to 2, therefore, right, it's the ratio of the leading coefficients, in this case, 2/3. That's your HA. All right, moving on to our x-intercepts. Set the numerator equal to 0, right, as a shortcut. And you're going to get that same exact case here, where I'm going to get something that's not real. If I extract the square root, plus or minus -1/2, right, you can't take the square root of a negative. Not real, but that implies that there are no x-intercepts. The graph doesn't have to touch the x-axis. All right, y-intercept is a little bit more as usual, right? You plug in 0. You're just going to get 0 plus 1, 0 plus 1, which is 1. And then last but not least, our domain. Typically, we need to exclude, right, our vertical asymptotes, right? But we don't have any vertical asymptotes. And we also need to exclude any hole values. Well, we don't have any hole values. So if there's no exclusion, this particular rational function is actually all real. Okay? So in your notes, I provided 2 more problems, 6 and 7, okay, as a try. So try that on your own. The solutions are already provided for you on the PDF document, so you can kind of take a look. So I would just cover it up, try it on my own, see if I really understand the concept of how to analyze rational functions. And if you have any questions, obviously always feel free to ask me.